This is Photon, an elementary particle. Actually, though, there's very little elementary about him. In fact, he's a puzzle to scientists because he's a corpuscle, but he has no mass. And he's also a wave that carries energy. Photon is light. In fact, photons are the fundamental elements that make up light. And it's thanks to photons that we can see colors. If photons of different energies strike an object and are all absorbed, we see the object as black. If, on the other hand, they're all reflected, we see it as white. And if some are absorbed and some are reflected, we see a combination of the reflected colors. Light is fundamental, not only because it enables us all to see, but also because it helps scientists to understand the world around us, and astronomers to study the stars and the universe. Yes, because astronomers study photons emitted by stars, which have different energies. And the hotter the star, the greater the energy carried by the photon. But a star's color also depends on its temperature. Did you know that stars are different colors? Blue stars are super hot. You know when you have a really high fever and your temperature is 40 degrees Celsius? Right. Well, the surface of a blue star is around 750 times hotter than your fever. A white star around 250 times. A yellow star almost 150 times. And a red star, the coolest, almost 70 times. And yes, that's the exact opposite to our taps. The hotter the star, the bluer it is, whereas the cooler ones are red. But how do photons that leave the stars make it all the way to us? Well, they're super fast. Although they have different energies, they all move at the same speed, around 300,000 kilometers per second, the greatest known speed in the universe. In 1 second, they could circle the Earth nearly 8 times, or travel between the Earth and the Moon in less than 1.5 seconds. The Earth is 150 million kilometers from the Sun. That's a huge distance, but not for photons, which reach us and bring us light within just 8 minutes of leaving the Sun. Yes, technically, if you're watching a beautiful sunset, the Sun has actually already set. And when we look at a star much further away than the Sun, the light we see left a long time ago. For example, if a star is 70 million light-years from Earth, the light we see was emitted by the star when dinosaurs lived on Earth and before man existed. All celestial bodies like the Sun, other stars, and galaxies emit different kinds of light, which make their way to our telescopes in their super-fast race through space. Ah, here are the 7 super photons. Gamma photons are emitted during huge stellar explosions. They have the most energy and are the most powerful, like those during a nuclear explosion. X photons have a little less energy than gamma photons. They are emitted by high-temperature sources. They are invisible to the eye and include those used for radiography. UV photons, which are also emitted by the sun, cause us to tan, but beware and make sure to use sun cream. They are really strong. Then there are optical photons emitted by almost all celestial bodies. These are the only ones we can see with our eyes, and we call them light. Last up are infrared, microwave, and radio. These are emitted by very cold stars, for example, and by interstellar dust clouds. They are weaker because they carry less energy, and it's thanks to microwave and radio photons that we have mobile phones, TV, and radio. Space is full of these kinds of photons, but they don't all reach Earth because the Earth's atmosphere only lets those that are not harmful to us through. Gamma, X, and UV photons can't get through and are observed by telescopes in space. while optic, radio, and some infrared photons are studied by astronomers using telescopes on Earth, helping us to learn more about the cosmos all the time. As Einstein declared, everything around us is made up of energy, which transforms through continuous processes occurring in nature, which often we can't perceive. Human beings are alive thanks to continuous processes of transformation of energy in the body and in our surrounding environment. But what happens if photons come from much further away? From another galaxy, for example? The adventurous photon certainly won't be deterred. Until the next adventure.